Tonight, we have a speaker from the Coral Restoration Foundation. I connected with these guys at the DEMA show this last fall. They've got a really great program down in Key Largo, Florida. They also have lots of opportunities for people who want to get more involved and actually help with the coral restoration. So I thought it was a great opportunity to have these folks talk to us, tell us a little bit about their story, and let us know what opportunities there are for us to help out as well. So, Cayla, if you're ready. So.
Yes. Hey, everyone. How are you?
Okay, Chris, I'm going to need your help.
My name is Cayla. Can everybody hear me?
Yeah.
Yes? Okay, awesome. My name is Cayla. I'm actually an intern here at Coral Restoration Foundation. I've been here for about a year now, and I have, been working on hands-on coral restoration. I do a lot of dealings with education, like what we're doing right now. And I feel like I've gained a lot of valuable information, so hopefully I can answer some questions today and give you kind of an overview of what CRF does, the importance of coral reefs, and how you can get involved. Okay, so I'm going to go ahead and share my screen to see if you guys can... Are you guys able to let me share my screen? It says that I need some access for that.
Oh, okay, well.
Yeah, if you just give me access to sharing my screen, I can go ahead and put that presentation up and we can...
Okay. There you go. There you go.
All right, perfect. All right. Great. Everyone can see the presentation?
Yeah.
All right, fantastic. So let's go ahead and get started. So corals, believe it or not, are an animal, and they're actually one of the oldest animals that have existed in shallow seas. They've existed for around 500 million years. So that makes them not only some of the oldest marine species, but some of the oldest animals on Earth as a whole. They also create some of the most biodiverse ecosystems known as coral reefs, which you guys are probably very familiar with. So coral reefs provide vital ecosystem services to us and to other marine species. However, since the 1970s, reefs around the world have rapidly degraded. Coral reefs have become one of the most threatened habitats on Earth. So stony corals like staghorn and elkhorn are some of the most at-risk groups of animals facing extinction. So in this picture here, this is something that we would call a coral graveyard. So as you can see, there's a lot of algae, it's really brown and sandy, and those lumps in the sand are actually pieces of coral skeleton. So this is not a very pretty sight. If you were a diver, you wouldn't want to see this when you go out. So we know that coral reefs have a global value. There are at least 500 million people around the world that rely on coral reefs for food, coastal protection, and livelihoods. So think fishermen, people who live in hurricane-prone areas. And we also know that the economic value of coral reefs is estimated to be about $10 trillion. So that's all the people who are fishing, selling it, all the restaurants that are selling fish sandwiches, people who go for tourism, things like that. And unfortunately, there is a global threat to reefs all over the place. We have lost about 50% of the world's coral reefs in just the last 30 years. That's a lot. And in the next 80 years, we expect we hope that all shallow water coral reefs are still here. They're facing extinction, and so that could be a reality in 80 years. We don't want to think about that, but it might be the case. And Florida's coral reef is actually a natural wonder. It's the third largest barrier reef in the entire world, right here in our backyard. So y'all are probably familiar with the other two largest coral reefs. In Australia, we have the Great Barrier Reef. Everybody has seen Finding Nemo. Down in Mesoamerica, we have the Mesoamerican Reef. So that's around Belize, Central America. And our reef here is 360 miles long. So that stretches all the way from West Palm Beach down past Key West to the Dry Tortugas. So Florida's coral reef is a vital ecosystem. It protects the coastlines, during storm surges and flooding and make sure that our infrastructure is nice and safe. It's a habitat for fish that are targeted by recreational and commercial fisheries. So people who go out for fun and also people who go out to catch fish to sell to restaurants and supermarkets. And this reef also supports the region's tourism industry. Plenty of divers and snorkelers love to come down here from all over the world to hang out in one of the world's natural playgrounds. However, Florida's coral reef is also a reef under threat, just like every other one in the world. Unfortunately, Florida has lost about 98 to 99% of its original stony coral habitat since 1970. And 90%, 97% of the dominant reef building species, like in this picture here, you can see elkhorn, they have been lost, 97%. That's a huge number. And it's only compounded by just last year, we had a very intense bleaching event that you guys might have heard about. So the level of degradation that we are seeing here in the, not here, but in the barrier reef now. So we hear a lot about the Great Barrier Reef struggling, a lot of bleaching going on there, disease, degradation. That's what the Florida Keys experienced already in the 1970s. So we are decades ahead of them when it comes to the degradation of our reefs. So thankfully, we're able to help them out because we have seen what degradation looks like. We're able to work with organizations all over the world to give them kind of a heads up of what to expect if restoration doesn't happen right now. And this is where Coral Restoration Foundation comes in. So CRF has the opportunity now to intervene and come up with restoration methods that, like I said, can be used all around the world to help slow that global degradation. So let's take a quick pause and we're going to go ahead and look at one reef here in the Florida Keys. We're going to study carries for it throughout time. So if you're not familiar with the Florida Keys, Carries Fort Reef is a little bit north of where the Coral Restoration Foundation is based. Over to the left, I guess, of your screen, maybe to the right, you can see some land. You see a bridge that goes to the mainland that connects Homestead to Key Largo. That's the stretch. That's how you get into the Keys. Coral Restoration Foundation is a little bit south of that, and then Carries Fort is a little bit north, away from some of the more commonly visited reefs up near Ocean Reef Club. So this is what Carries Fort Reef looked like decades ago. This was beautiful. 1970s, it is prime time. It's beautiful and healthy, and this is what divers want to see when they go down diving. We have elkhorn coral as far as the eye can see. It's healthy, it's brown, we have fish swimming around, and these corals are actually about 3 to 5 feet tall. So underneath what you can see in this picture, we might have species like eels swimming around, lobsters, crabs, and in the background, you might have sharks who are also depending on this reef, you know, nurse sharks, reef sharks, hammerheads even. They're all just loving this healthy reef right now. And so just 10 years later, this is what the reef looks like. As you can see, we're starting to see more of that algae. This is a huge difference from what it was just 10 years prior. And then a few years after that, and then most recently. This is 2014. This is a shocking change compared to what Carries Fort Reef used to look like. This puts a pit in my stomach just looking at it. This is no place that a fish wants to be. This is no place a shark wants to be. No place that a diver wants to be. You know, this is that coral graveyard that I talked about earlier. We have no more structure. It's just algae. It's just brown. There's no fish, not a lot of life at all. And so how does this happen? How do we get to this point? So there are a lot of local stressors that impact the health of coral reefs. So these are things like direct human impact. So this is damage from divers and snorkelers when they're kicking and their fins hit a coral. You know, this is back in the day when souvenir shops used to blow up coral with dynamite to collect pieces and sell it to tourists. And then also poor anchoring and boating practices. You know, like I said, corals are 500 million years old. It takes them centuries to grow to a massive size, and that can all be destroyed in just a second by someone dropping their anchor someplace they shouldn't be. Another issue is the disappearance of herbivores. So for any of you that have dove in the Caribbean, you've seen parrotfish. Parrotfish are beautiful fish. You know, you don't really eat them here in America. That's not something that we do because we like to look at them more than we like to eat them. But in some places, they are overfished and they are eaten, and that leads to less parrotfish around eating that algae that can take over corals. Another herbivore that was wiped out was in the 1980s, long-spined sea urchins. They had a disease event and a lot of them died. And these herbivores are what helped to fight back algae from competing with coral. And so now what we're seeing is a shift from that coral-dominated ecosystem to an algae-dominated ecosystem. And algae just doesn't do the same things for us that coral does. So it's not as helpful to us or the environment. Development and pollution. So here in the Florida Keys, rapid development over the last 50 years has increased nutrient runoff and sedimentation. So while we're not 100% sure the direct cause of diseases that impact corals, you can make a pretty good guess that dumping sewage into the water, dumping chemicals into the water may not be the best and healthiest option for them, right? So these corals are getting sick from just a general degradation of water quality in the Florida Keys. Thankfully, we've gotten a lot better at this with, better sewage management, more mindful construction, but sometimes damage is done. So, and lastly, another local stressor is chemical sunscreen. So you guys might have heard about this as well. There are a lot of chemicals in popular sunscreens that can be lethal to corals and baby corals. Even before corals get a chance to grow, their little babies are being killed by these chemicals in the sunscreen. So these are things like oxybenzone, avobenzone, oxanoxate. Basically, if you're not buying sunscreen that is zinc only, so mineral only, there possibly can be chemicals in that sunscreen that is hurting these corals. And when you have millions of tourists coming and swimming in the ocean every year wearing that toxic sunscreen, it does start to add up. And so on top of these local stressors, which people have been doing a great job in the community of fighting against, sometimes it's harder to go against these global stressors. We know that global greenhouse gas emissions have caused ocean warming and ocean acidification. So these increasingly regular, sustained warm water events are causing coral bleaching. This is what we experienced just last summer. And increasing ocean acidification is impacting the coral's ability to grow their calcium carbonate skeletons. So that's the same thing as limestone. And this is the same thing that snails have their shells made out of, the same thing that clams have their shells made out of. So over time, a more acidic ocean means softer skeletons, softer shells for these animals. And that just causes a whole nother problem in and of itself for where they're going to live, how they grow, and how strong they are. And another thing that we do know is that climate change is anthropogenic. It is caused by the actions of humans, and that presents the biggest threat to our world's coral reefs. So why should we care about coral reefs? Just 0.2% of the ocean floor is covered by coral reefs. That's less than 1% of the entire ocean that is covered in coral reefs. However, 25% of marine animals are supported by coral reefs. So this means whether you're in New York or Florida or Europe, if you order a grouper sandwich on the menu, chances are that fish came from a coral reef that just covers less than 1% of the ocean floor. So that is a big population that is sustained by a very small area. That's why they're so important to maintain. So in these pictures here, you can see a healthy coral reef versus a degraded coral reef. Up at the top, you can see a beautiful, healthy reef. There's structure, there's divers that are wanting to check out all the coral, there's lots of fish, dolphins, there's people that are fishing up at the top there. And as we can see, because of that structure, that wave energy from hurricanes and from storms is broken apart so that they don't reach the coasts. And so we have mangroves that help to solidify our coastlines, and our homes are safe from storm surge, from tsunamis, things like that. But then on a degraded coral reef, we lose that structure. We don't have as many fish. We don't have any divers because they don't want to see the fish. We're losing out on that tourism. Fishing becomes less successful. You're catching less fish. And now that wave energy from those storms is still impacting the coasts. And now our homes are at risk. Our roads are at risk every time there's a storm. So here at Coral Restoration Foundation, when we restore a coral reef, we do this by growing and planting a coral. We grow them in the nursery, bring them out to the reef, plant them back on. And by doing this, we provide a habitat for marine life, over 1 million different species. We support the tourism and diving industry. We provide food for reef-dependent Fish, we provide food for us. We also help to regulate carbon dioxide levels. Corals help to balance, the carbon levels in the ocean and in the atmosphere. And then we also help to protect the coastline from those storm surges, from erosion. So that's what happens when you help to restore a coral reef. So let's talk a little bit more about Coral Restoration Foundation and what we do. So CRF is the world's largest nonprofit marine conservation organization dedicated to restoring coral reefs to a healthy state in Florida and globally. Our core mission is to restore coral reefs, educate others on the importance of our oceans, and to use science to further coral research and coral reef monitoring techniques. So large-scale massive action is required to save the world's coral reefs. We know that. So how do we do it? We work with stony corals. In this picture here, this is a staghorn. I showed you the elkhorn before. And these are recognized by multiple agencies as being under threat. They're listed on multiple endangered species lists and endangered species lists. So our primary focus is growing and outplanting staghorn, which is the top picture, elkhorn, the middle picture, and different species of boulder corals. We're actually trying to do more boulder corals because we found that last year during the bleaching event, boulder corals actually had a higher resilience to higher temperatures. So we're going to try to start to put those into our regular outplanting rotation as well. So having these different species of corals is important to support biodiversity, and biodiversity leads to the resilience of an ecosystem. So we actually have a total of 20 species of corals in our nurseries. So the way that we grow coral is through propagation. This is by fragmenting a piece of a coral, and it's a part of an asexual reproduction process. So this is similar to if anybody has ever cut a leaf off of a plant and then put it into a vase of water, and then a couple weeks later that plant has new roots. That's the same thing with corals. So if you cut off a piece of a coral, not only will that coral grow back that piece, but that little piece you cut off will now grow back as a whole new coral in and of itself. So originally, to start up our operations, we would harvest some fragments from wild, healthy colonies in the Florida Keys. But now our coral tree nurseries are self-sufficient. We no longer have to go back out to the reef and take wild corals. We can just grow them on our trees, fragment them from there, and put them on new trees. And honestly, some of the genotypes that we have in the nursery don't even exist in the wild anymore. So if we weren't there to intervene and take them and take a sample and put them in our nursery, they wouldn't exist at all. So we use something called a genetic bank to preserve genetic diversity. So I just mentioned biodiversity, and now I'm talking about genetic diversity. What's the difference? So biodiversity is many different species. So if you go into a room, you have a cat, a dog, and a human and a bird, that's biodiversity. You have many different species. When it comes to genetic diversity, that would be a room full of people that all have different traits about them. Maybe somebody is stronger than somebody else, someone is taller, someone is shorter, someone has dark hair versus light hair. Things like that are different genes. So genetic diversity is important to ensure resilience of a single coral species, so that help to make up the entire coral reef system. So we do this because one genotype of the same species might be more resilient to a disease than a different genotype. So if that disease comes rolling through, we want to make sure we have many different genetic makeups of the coral so we don't lose all of it during one event. So CRF, to preserve genetic diversity, we actually work with 1,250 genotypes across 20 different species of corals. So to help us to grow corals as quickly as possible, CRF developed the coral tree. So that's this picture here. It's recognized as one of the best methods for growing large quantities of certain species of coral, like elkhorn and staghorn, very quickly. Each tree can hold about 60 corals. So what I'm going to ask you guys to do now is take a look at this coral tree. These are these little tiny fragments that I was talking about. Go ahead and just pick one on this tree. Keep your eye on one of those corals, and I'm going to show you what it looks like when they're all grown up. So this is that same coral tree just 6 to 9 months later. So your little tiny fragment has now grown to be about football sized. So these observations show us that coral trees grow way faster on these trees than if they're attached to the ground. And it's not just one tree that we have. It's not just a dozen trees. It's an entire coral nursery. We have several coral nurseries throughout the Florida Keys, and together they can hold more than 45,000 corals. So that's a lot. That's huge numbers here that we're growing, propagating, fragmenting every 6 to 9 months. We can increase those numbers more and more rapidly. We're constantly expanding these nurseries to hold more corals. So how do we get these corals from the nursery back to the reef? So in the nursery, these reef-ready corals are harvested. So we fragment a little piece off of those big ones. We group them by the same genotype and we place them into crates of water. These are then transported by boat to a restoration site. So since 2007, we have focused on the restoration of more than 34 reef sites. So how do we choose where to outplant? So one project that we're working on with NOAA is Mission Iconic Reefs. This is one of the most ambitious reef restoration plans in the world, with NOAA and with other partners as well. So this collaborative effort focuses on the restoration of 7 iconic reef sites in the Florida Keys, including that Carysfort Reef that I mentioned earlier. And we're planning to restore a total of 64 football fields equivalent of coral over the next 20 years. That is a huge amount of restoration, and all the way from Key Largo down to Key West. So we got those corals in the crates, put them on the boat, brought them to the reef site. So now we're going to outplant them. So corals of the same genotype are attached to the reef using a marine epoxy. So kind of like a Play-Doh if it was a glue. So we attach those corals to the reef and we try to cover as much of an area as possible, keeping about a foot between each piece of coral. So keeping them this close helps to encourage fusion. So fusion is when the corals start to grow. They actually attach to each other over time. That's a very good sign for a healthy reef. And this also helps us to restore areas on a massive scale, with just blanketing the reef with these corals, which is great. And so it works. And how do we know that? The data shows it. So our science program monitors our outplants just like they always have. But at first, CRF monitored these tagged outplants with just a paper and pencil, and that allowed us to only capture a random sample of about 20 outplants each time. And in 2017, our data showed that over that 1 year, we had a survivorship that was an average of 77% across all sites and species. That's pretty good for such a delicate animal. However, we realized that this methodology was pretty limiting. You can only have a certain number of people who are writing down things. You're only getting about 20% of all the outplants. So data is not as accurate as it could be. And it's difficult to maintain this method as we became a bigger organization working on a larger scale. So what we do now is we use a method called photomosaics. So this picture right here is a photomosaic. So the way this works is we have our restoration team. They have this device. It's a long PVC pipe with 2 GoPros on either end. So we call it the hammerhead because it has like the eyes on each end. And so our team members will swim over a large reef, the entire reef. They'll swim back and forth over the whole reef, and they will take hundreds of pictures. The GoPros are just snapping pictures the whole time they're swimming. When we get back to the computers, we will stitch all of those hundreds of pictures together to create one massive picture of the reef, the entire reef. And it's so high definition that we can see each individual coral on the reef. So forget pen and paper where you don't know which corals you're talking about, you don't know where they are, you can't go back to them later. With this method, we can look at every single coral and we can go back a year later, 2 years later, 5 years later, and be able to point at the exact same coral that was outplanted in the past and see how it's doing. So this is a great way to collect data and be more accurate with it as well. So in 2016, there was a 10-year published scientific study that showed us that anywhere that CRF was doing restoration, the trajectory of staghorn coral populations increased, and any place where restoration was not being done, the population trajectory decreased. And before you say, well, duh, this shows that not only are we just preventing the reef from getting worse, we're actually making it better. If we weren't doing anything at all, these reefs would continue to degrade and degrade and degrade. But because we are intervening, we're making a difference. We are making this reef better than how we found it, which is the best thing that we could do. So these are outplanted corals that have fused together into one big colony. So these corals have become just one giant piece of coral, and now it has places for fish to live. It's more resilient because it's stronger with its skeleton. This is a good sign of a healthy reef. Another good sign of healthy outplants is when they begin to spawn. So outplants that we have put back onto the reef have started to spawn in as little as 2 years after being outplanted. So spawning for a wild coral sometimes doesn't occur for decades after it's rooted and then grown. It can take decades. But for us, the fact that it's happening just 2 years after outplanting them is a huge sign that our outplants are thriving and are kickstarting the natural process of recovery. So do you remember Carrie's Fort, that case study that we looked at the beginning? This is what some of our fresh elkhorn outplants look like back on Carrie's Fort Reef. So these pictures show the new growth of our outplants compared to that old mortality that we're building upon. So this shows that ecosystem level recovery is possible. Could you have imagined by looking at that coral graveyard that it would ever look like this again? It can be hard to imagine until you see it with your own eyes. So here it is. Carrie's Fort Reef is starting to recover because of the work that we're doing. So since 2007, we have returned over 210,000 corals back to the reef. That is a huge number. As you can see here on the left, that's Carrie's Fort Reef in 2017. Those are just elkhorn outplants that are 9 months old. They were on the reef for 9 months. They're little tiny babies. And then just 4 years later, look at that growth. They're huge now. They're providing habitat for fish. They're providing that structure for the reef and protecting us from that wave energy. That's exactly what we want to see across all of our outplanting sites. So now back to you guys. Your choices matter. So there are many ways to be an ocean steward. There's many ways to get involved and make a difference. So there's, like I said, many ways. We may not have to choose every single one. It can be hard to shift your lifestyle in such a drastic way, and we understand. No one's perfect, but you can always do little things here and there to make a difference. So for example, you can consider a plastic-free lifestyle. So that's something that I do. I have my reusable water bottle. I get to put awesome stickers on it. It's a great way to help prevent plastics and waste from getting into the ocean. You can also switch to reef-safe sunscreens like those mineral zinc-based sunscreens. And you can also just spread coral reef awareness. Tell your friends about the importance of reefs. Tell your fellow divers about why they should visit reefs so they can really see how important and beautiful they are. So choose your change. Find the cause that speaks to you. Every ecosystem is connected and every positive action matters. So whether you live in the woods up north or whether you like to spend time on the lake or on the river, every ecosystem is connected. Every difference you make can help the corals and help your environment as a whole. So find what you can do in your local area to make a difference. So you can still get involved with CRF also in many different ways. You can come down and visit on a dive program. So this might be a great option for your entire group as a whole. So the SeaDevils are always welcome to come down here and do a dive program with us and go out and see what we do and what interns and staff do on a daily basis. You can also, if you live in the Keys or live near the Keys, you can come down and be a volunteer. So this would be land-based or water-based, more of a long-term commitment, and you can work right alongside our staff and interns. And another way to get involved is through education, which you can applaud yourself. That's what you're doing right now. You already took that step to learn more about reefs and learn more about what you can do to be an ocean steward. You can also show your support to CRF through donations on our website or by mailing checks in. And then we also have our CRF merch, which is made from a lot of recycled materials and helps us support programs like the internship program, helps us to fuel our boats, buy restoration materials, and just keep things up and running. And also you get to look pretty cool wearing your CRF merch, I'm just saying. So we'd also love if you guys kept in touch with us. You can visit us in person if you're ever down here at our Exploration Center in Key Largo. You can also follow us on social media. We have Instagram, Facebook, Twitter, all that. And you can also sign up for our newsletter, Coral Chronicles, on our website to keep up to date with what we're doing and what we're working on. And so I just want to say thank you guys once again for being willing to learn about coral restoration, taking that first step to being that ocean steward. And we appreciate you and hope to see you guys down here if possible. And also, I'm here for any questions if you guys have any.
Any questions from in here? So Elizabeth.
You relay it.
Okay.
She mentioned that the algae will eat coral if it's not kept be controlled by the herbivores, so that they need to import new herbivores to protect the new coral?
Did you get that?
Could you repeat it, please?
Yeah, so I'll try. So you said that the coral gets attacked by algae. Do you need new herbivores to protect the coral that you're planting?
Yeah, so it's not necessarily like a predatory situation. It's more so the coral and the algae, they eat the same things. They both, eat little tiny things in the water. Coral and algae occupy the same space. So it's not like the algae are attacking the coral necessarily. They're just competing with the corals for those same resources. So that's the issue. And so those herbivores, what they do is they help to just keep that algae trimmed down so it doesn't become too overwhelming for the coral. And so there are some things in place to help bring back herbivores. So a lot of islands in the Caribbean where they used to eat parrotfish have actually implemented new regulations to prevent the overfishing for them. And that has helped their populations to bounce back a lot as well. And with the long spine sea urchins, even though a lot of their populations were wiped out by a disease in the 80s, we have found that they are making a recovery. While it might be a little bit slow, they are coming back. And so the best thing we could do now is just put protections in place to keep those fish populations healthy and thriving.
Other questions?
You look at the coral and you say, okay, the coral has died when the conditions were in. And now you're putting good fresh coral back. But you haven't changed the conditions. It's like, I don't know how it's, it's more resistant to the conditions than what was originally given.
Did you get that?
Sorry.
Okay, so the point was, the conditions haven't changed. So why do you expect your new coral to survive when the conditions haven't changed?
Yeah. So that is a question that we get asked pretty often, why do you keep going if it may seem like a never-ending battle? And like I mentioned on one of these slides, if we weren't doing anything, these reefs would already be lost. Everything that we do, every action, every coral that we put back on the reef is one more coral that is there to provide structure, provide habitat. And if we weren't doing anything, these populations would just decline even more rapidly. And so how do we know that the corals we put down in the future are going to even survive? What we know is that the corals that are still alive today are the most resilient corals of them all. A lot of corals were wiped out over the years. There's been many bleaching events, and corals sometimes didn't make it. Entire species didn't make it. But what we have now are the strongest of the strong. They're the most resilient. And so we can feel confident that by putting these corals back out, they have the highest chance of survival. So we can just hope that these corals that are still remaining will spawn with each other and create more resilient offspring. And, natural selection will do its thing, and corals that we still have will still be strong and only stronger in the future. But that's still not, a reason to stop what we're doing. We're making such a big impact. Well, whether it's small or large, if we weren't doing anything, things would be a lot worse.
So I had a question. You were talking about the different genotypes. Do you take a look at the genotypes and match them with the area? So kind of on the heels of that last question was kind of perfect, of looking at what the environment is and matching the genotypes for the strengths for whatever the situation might be bringing.
Yeah, so that's actually a really interesting concept. So I'm not sure if you guys have heard about supercorals. There are some other organizations that work with supercorals, and these are corals that are genetically modified or grown in aquariums, in labs, with genes that are supposed to make them stronger. So these are scientists that are going in and making corals that are supposed to be more resilient to bleaching and more resilient to certain diseases. But the issue with that is you're putting all your eggs in one basket. So if you make a coral that is, very, very resilient to bleaching, how do you know it's going to be resilient to a random disease that comes through? That's not what SeaDevil does. What we do is we want to promote natural recovery and natural resistance. So when we put corals on the reef, we will put down 10 different genotypes in the same area because we want these corals to have their best fighting chance, and we don't want to just put one genotype in one spot. So what if something happens that we didn't expect and now all of those corals have been wiped out? It's better to have genetic diversity. That way, some of these corals will be stronger than others. Some will be more resilient than others. Some will be more susceptible than others. All we can do is hope that natural recovery and natural selection plays its role, and these corals are able to develop their own resilience over time and not just have us like pick and choose which corals we think will be best in what spot, you know, because then now we're causing too much of an interference, and it's best to let nature kind of develop its own resilience in this case.
So we had a question online.
Actually, oh,
Go ahead, Mary Lou. I was going to read your question.
oh, hello. Well, I actually have a new question because she kind of answered my written question. So, great work. Love what you're doing. Thank you.
Thanks.
I would like to ask, you mentioned that you are currently using populations from your coral trees to continue your outplanting and not going back to the reef. I'm curious though that after big bleaching events or other events that do a lot of damage, if you are going back and potentially resampling or taking frags from some of the corals that did survive to increase, you know, the population of corals in your nursery that are more resistant.
Yeah, so we definitely are keeping track of which genotypes and which species were the most successful during these events. We are absolutely keeping track, but instead of having to take a fragment and test which genotype it is, we have all of our outplants labeled with their genotype. So we just have to swim back over the reef, take some more photo mosaics, look at the tag with their genotype on it, and just take a note that that genotype is still alive, that genotype didn't struggle very much, and then we know that those genotypes will do well in the future. Of course, you know, like I said, we don't want to pick and choose which ones to propagate, which ones to ignore. We don't want to ever ignore any of these endangered animals.
Uh-oh.
So we do keep track of which genotypes do better and which ones don't.
Thank you.
Yeah, of course.
So, question, go ahead.
Where else in the United States are you doing restoration work besides Florida Keys?
Yeah, so if you guys have been following our social media, you might have been up to date that we have made some more expansions recently. So we don't work outside of any other state besides Florida. We just work from Key Largo down to Key West. But we do have some new plans in the works to expand globally. So that may include, you know, US territories and partnerships with organizations around the world. While we may not move CRF to a different country, we will work with practitioners around the world to share what we know, to share, you know, what has worked for us and learn from these different communities as well. So we definitely have plans to, you know, expand.
So I had a question. So how long do you leave the coral on the trees?
So we leave the corals on the trees. Right now, we're not outplanting because we usually leave outplanting for the summer. We give corals. So just to give you like a quick timeline of what a year looks like for us, we will put up fragments of a coral on a tree, usually in the fall and the winter time. That way, by the time summer rolls around, these corals have grown. They've had about 6 to 9 months to grow larger, and then we go ahead and fragment them. Those corals that are on the trees, like that we fragment from, will stay on the tree. These coral trees are usually never empty unless we're, you know, moving them or taking them down because they're old. But we will fragment the same corals for years. Those corals will grow branches, we'll cut it off, and then plant those on the reef. And then that original coral will keep growing branches and we will keep using it. So it's really helpful that way because corals are so, really cool with the way that they fragment that way. Just like a plant, it's like they never run out. You cut off a piece and now you have two corals. It's great.
So in the areas that you have transplanted, have you also noticed an increase of fish population?
Yeah. Oh, yeah. These fish are super grateful for what we do. And you'd even be surprised the ecosystem that grows in our coral nurseries. Like, I feel like I see sometimes more fish in the nursery than I see out on the reefs because we have so many corals and so much structure, and it's so healthy there. The fish are just drawn to healthy corals. And even in our nurseries, you'll see different species. You'll see sharks, you'll see rays. It's really cool. So yeah, our corals definitely attract a lot of species.
Very good. Any other questions? Well, thank you, Cayla, for your presentation. Just so you know, I will be down in Key Largo at the end of May, so I will swing by. So
Yeah, of course. We would love to have
good.
you and anybody else here. Thank you,
very
guys.
good. All right, thank you. Share, so. All right, so the next meeting, May 8th, Gary Powell will be here talking about or sharing his photography of the Blue Heron Bridge down in Florida. So lots of good pictures to see. Would love to have you back.